So now the question, we've been given a vertical shaft of 20 mm in diameter and 60 mm long, is held in short bearings at the ends. We are told that we have a 5 kg disc mounted on the shaft midway between the bearings. So the center of gravity of the disc is 0.5 mm away from the axis of the shaft. Okay, so if the allowable tensile stress for the shaft is 17 per millimeter square, determine the critical speed of the shaft in RPM, revolution per minute. Okay, so these are the values we have given. From the diameter of the shaft, which is 20 mm, we can calculate the area of the shaft. We already told the length of the shaft is 600. The mass of the central disc is 5 kg. So that means we can get the weight to be 5 times 9.81, that's 49.01. The distance E from center of gravity to the center of the shaft is 0.5 exponential minus 3 meters. So we've converted millimeter to meter. Okay, so now if the shaft were to be horizontal, in horizontal position, this is how it's going to be. Okay, so we have bearing at point A, we also have bearing at point B. We are told that the disc is midway. It means since it is midway, from here to here is 300, from here to here is 300. Okay, so now the weight here is W. It means the weight acting on this bearing and the weight acting on this bearing will be equal, will be the same, and that's W over 2, W over 2. So but meanwhile, anytime we have this kind of configuration, static, we are going to find, we are expected to find the static deflection. The static deflection is given by WL cube over 48 EI. Okay, so where the I is given by the moment of inertia of the disc, and this is the formula for moment of inertia of the disc. Okay, D is the diameter of the shaft, so it means your I eventually gives 7.85 exponential 3 millimeter raised power 4. Okay, so now that we know I, we are also given E from the question, we are also given L from the question, we calculated W. From there we're able to get the value of our static deflection. Okay, so that means our static deflection is going to be 0.14 millimeter. Okay, that's after substituting the values of W, L, E, and then I, we're able to get the static deflection. Okay, we're able to get the static deflection of 0.14. Okay, so now the critical speed omega c is given by square root of q over m. It's also given by square root of g over static deflection. Okay, so we already calculated the static deflection as 0.14 millimeter. So 0.14 millimeter is same thing as 0.14 exponential minus 3 meters. Okay, so it means the critical speed is going to be 264.71 rad per second. Okay, so but from the question, we're expected to calculate the critical speed in revolution per minute. Okay, since we are calculating the critical speed in revolution per minute, it means we have omega c equals 2 pi nc over 60. So making nc the center of the formula, we are going to find our speed as 2527.8 revolutions per minute. And so this is the final answer.